Okay, that's a lorry traveling with constant speed of 42 meters per second passes P along a straight level road where PQ is 2,936 meters. 15 seconds later, it starts to decelerate uniformly at 0.6 meters per second. At the same time as the lorry passes P, a fan starts from rest at Q. So, the lorry is in blue, the van is red, and it's over here. Okay? And so what's happening is the distance covered by the lorry, in whatever way, shape or form that takes, plus the distance covered by the van, that has to equal the entire distance of 2,936.5. So let's start off with UVAST of the lorry. So UVAST. So the lorry travels for 15 seconds at a velocity of 42. Well, 42 times 15, because it doesn't have any acceleration, is 630. So part of this is 630 that was travelled at constant velocity. The rest of it is an equation that we're going to have to figure out. Okay? So, after 15 seconds, we're at 42. Okay? And our acceleration is minus 0.6. And our S value is S lorry, or yeah, we can just call it S subscript lorry, S lorry, okay? And the time frame is it's your total time of when the two of them meet each other. So it takes T seconds for the red van and the blue lorry to hit in the middle somewhere, okay? And it's not necessarily the middle, just somewhere along the path of P to Q. But the time you spent traveling this distance here, SL, is basically T minus 15. It's your T value, take away 15 seconds, because you've already used 15 seconds, okay? So we'll get SL now. So it's going to be UT plus a half AT squared. So it's going to be 42 times T minus 15 plus a half minus 0.6 times T minus 15 squared. Okay? So that's the blue region in there. Alright, now we might as well expand it a little bit. We'll go for 42T minus 630. And then we have what's this going to be, minus 0.3, and then T squared minus 30T. What's it 225 down for 15 squared? 225. Then we're going to multiply all this out. We're going to get 42T minus 630, and then we're going to get what's it, 0.03 T squared. 3 by 30 is 90, and then that's 225 by 0.3. That's going to be an interesting one. It's not going to be the nicest number I've ever come across, but we'll give it a go. Yeah, it's going to be 67.5, which is an awkward number. And then the blue number is all going to come to minus 0.3 T squared, 51T, and then 630 minus 67.5. Oh, sorry, added together, my bad, is minus 697.5. So the blue region, which is your 630 plus your SL, so the blue distance altogether, the total distance covered by the lorry, we'll do that in a second, because I suppose I have written this down as SL. Okay, now as for the van, Right, the van starts off at a speed of 0 and it has a maximum velocity of 28 and it has an acceleration of 2 and it has an s and a t. Now v equals u plus at, 28 equals 0 plus 2 times t equals 14. It takes 14 seconds to reach the maximum velocity. In this time, s is equal to ut plus a half at squared. It's going to be 0 times 14 plus a half, 2 times t squared, which is 196 meters. So the van covers 196 meters. Sorry, the fan covers 196 meters in its first 14 seconds. Now, in the remaining time, which we'll call s van, and the remaining time is t minus 14 seconds, okay? So now we're going to calculate its distance sv, okay? So sv is going to be, sv, it's going to have a starting off point of 28. It's going to have a it's not going to be accelerating anymore, so it's going to be acceleration of 0, and the s value we don't know, which is sv, and the t value is t minus 14. So it's just going to be ut plus a half at squared, but the a value is 0, so it's going to be 28 times t minus 14, and then plus a half a, which is half 0, so it's just going to be 0. So it's going to be 28t, 14 times 28 is minus 392. Okay, now let's put all this together. Okay, now this entire distance from here all the way to here, so I use a different color, from here all the way to here is 2936.5. So 2936.5, what does it equal? Let's go in line here. It equals your 630 to begin with. And then it equals your distance covered by your lorry, which is this part here, which is our minus 0.3 t squared plus 51t minus 697. Sorry, that all looks the same. 697.5. Okay, and then we're going to have our SV. SV is here, which is our I'll keep it all in black, 28V minus 392, and then we also have 196 up here. Now I'm going to add all the regular numbers together first. So that's this one, this one, this one, and this one. So we're going to get a 630 minus 697.5 minus 392 plus 196, and we're actually going to get a minus 263.5. Bring that over the other side and add it. I'm liking that, the two of them added together. Might bring something good in here. Minus 3,200 as it turns out. So that's minus 3,200. Okay, when I bring that over the other side and change sign. Now, the t squared, there's only one of them, it's your minus 0.3 t squared. Okay, now we have 51t, and that should be 28v, it's 28t. So 51 plus 28 is 50, I believe it's actually 59. So 51 plus 28 is 79, sorry, 79t. Now here's what we're going to do. We're going to bring this all over one side, and we're going to get 0.3 t squared minus 79t minus 3,200 equals 0. Not going to waste your time here, lads. Minus b formula, that t equals 50. Happy days. That's when they collide after 50 seconds. Find the distance between the lorry and the van after 56 seconds. Okay, after 56 seconds, we know that they hit after so we know the lorry and the van. Sorry, the lorry is in blue. The van, it was in red, and we know that 50 seconds in, the two of them are nose to nose, so to speak, or occupy the same points. In a way, you could treat them as like a blue particle and a red particle. Okay, best to treat them as particles. Okay. Now, what I'm interested in is after 50 seconds, what direction is the lorry actually going in? Because the lorry is always decelerating. So the lorry's initial value was 42. Now, 56 seconds in. So remember, it spent its first 15 seconds decelerating. Oh, sorry, at constant velocity, and then after that, it was decelerating. So 56 take away 15 is what's it? 56 take away 15 is 41. Has 41 seconds worth of deceleration going on here. And we know here A is minus 0.6, S doesn't matter, and our T is, let's just go for 41 here for argument's sake, okay? Actually, do you know what, guys? I think I'm going to reset the watch at 50. So I'm not going to use 56, I'm actually going to use 50. So I'm not going to use 41, I'm going to use 35. Because I'm just interested to see where it's going. 35, alright? So T is 35. So I don't think I think the lorry's still going to be moving forward no matter what, to be honest. So we're going to use V equals U plus AT. And V equals U, which is 42, take away, what's it, 35. Sorry, not 35. V, that's going to be minus 0.6. Now, what do we say about this again? We start off 42, 15 seconds in, so we're 35 seconds worth here. And our V value is 42 minus 0.6 times 35, 21. So the lorry is still traveling this way at 21. Okay, which is grand and handy. So we're traveling at 21 for another 6 seconds, which is handy. Now the van, which is traveling at constant velocity, however, so remember the van is stuck at 28, so it's UVST. This is not good for 10 o'clock on a Sunday night, but anytime I'm free. Now, the van is 6 seconds. It's stuck at 28 because it's fully and has no acceleration. So 28 times 6 is 168 meters. Okay. So we know that the van is going to travel to the right 168 meters. So now we just need to find the distance this travels to the left. So we use S equals UT plus a half AT squared. So S ends up to be equal to UT. So 21 times 6 minus a half of 0.6 is 0.3 times 6 squared. And I believe that's going to be 115.5. 115.2, my bad. Yeah, 115.2. Add the 115.2 that goes to the right to the 168 to the left, add the two of them together, you get a total distance of 283.2 meters apart. Right, happy days, that took a long time.